This is a doubt from exercise rate and order of the reaction. Crystal violet is an indicator which is colored in solutions of acid and it is colorless in alkaline solutions. The kinetics of the reaction of crystal violet with sodium hydroxide were investigated using the abbreviation CV for a formula of crystal violet. A simplified equation is there. Equal volume of 0.1 mole per dm cube sodium hydroxide and 5 exponent minus 5 moles of crystal violet. Explain why very different concentrations of sodium hydroxide and crystal violet were used in the experiment to find the order with respect to crystal violet. You can see we took very high concentration of sodium hydroxide and we took a very small concentration of crystal violet. What is the reason for that? It means we took excess of sodium hydroxide. So when we want to determine the rate or you use an initial rate method, so we take one of them in excess and another one is a limiting, so that we can work out, like here in this case we took sodium hydroxide in excess more than enough and crystal violet is a limiting reagent. So when we change the limiting reagent, we can work out how the rate of the reaction is affected. Otherwise, if both of the reactants are in a small quantity, that maybe the reaction might be affected by both of the reactants, or the rate of the reaction might be affected by both of the reactants. So reason of taking a very high concentration of a sodium hydroxide, so when the reaction occurs, sodium hydroxide will be in excess, or change in concentration of the sodium hydroxide won't affect the rate of a reaction. So rate will not be affected by sodium hydroxide, or rate is only affected by concentration of crystal violet. So the main reason of taking large concentration of sodium hydroxide, so it will be in excess and does not affect the rate. A change in the amount of sodium hydroxide won't affect the rate of this reaction. Suggest a method which could be used in this experiment to continually monitor the change in concentration of a crystal violet with respect to time. We want to continuously monitor. So what we can do, we want to observe or monitor this reaction. This reaction is taking place. So the problem here, we cannot use like that. Only one technique which is not acceptable is quenching, like taking out a sample, then quench and then either titrate with acid or alkali. The problem is that this crystal violet will change a color. So if you, for example, you take out a sample, you quench it, but you try to titrate with acid or alkali, then the crystal violet will change its color. That's why quenching is rejected. Rest, any other is acceptable. Like you can use calorimeter to observe this. You can also use conduction method. Like you can observe the change in conductivity. But normally, as the molecules are in aqueous, like all of them are in aqueous, so there will, like this crystal violet is also in aqueous. So it means the conductivity won't change at all. That's why conductimetry also cannot be used or done. So we can use colorimeter can be used, or we can use the same idea. But colorimeter is the most suitable technique can be used. Not titration, not conduction. Why conduction is rejected? Because as I check the equation, it is also aqueous. So aqueous means it is also for presence in the form of ion. So there will be no change in ion. That's why conduction is not acceptable. Then we have the graph which shows the concentration of a crystal violet changes. Measure two half-life of this reaction and show your working. So how we work out the half-life? Half-life means time it takes to become half of original. So example, I took 2. You can take any value. It's not fixed that you can take any value. You can take 2 half of 2 will be 1. Or you took 1, half of 1 will be 2.5. So each box is 10 boxes are 5, each box is 0.5. So this is 1, 2, 3. So this one is 3 and 10. So half-life 7. 10 and 15, 16, and 17.5, about 17.5. And this value, it's about like 10.5. So it's just 7.5 and 7.5 or 7.25. So the two half-life, one is about 7.5, or almost both are same. So if the two half-lives are same, it means this is use your half-life, reduce the order. So if half-life is constant, it means it is first order with respect to concentration of crystal violet. Then we have another series of experiment. The rate constant was determined at different temperature. The graph shows. So how to get 1 over T? You have to take a reciprocal, like, so 297, 1 divided by 297. We'll get 3.37 exponent minus 3. And this one will be, you have to take ln of 7.91. So ln 7.91 will be minus 4.84. So when you select the scale, see, you have a minimum value for 3.37 to for 3.51, and here for 4.8 to 5.7. So you don't have to select a full starting from 0. Plot a graph for ln k on vertical axis, which is from 4.8 to 5.7. So I can start with 4.8. And for x-axis, I can start 1 over t on x-axis. So I have a smaller number, 3.37. So I can start with 3.3, then 3.4, then 3.5. So if I start with 3.3, and this after 10, 20, 30 boxes, example, 3.4, and then 10, 20, and 30. I have 3. This is 3.5. To reduce the scale so that I can use all the values. So if I select this as a 3.3, 3.4, 15 boxes I took, then 3.5, then 3.6. Or if I try to further reduce, 3.3, 3.4, but this will be very small scale. I have to extend the scale. Better take more 15 boxes, so it will cover up about 50 or more than 50% of the. If I take 4 box, 20, 3.4, 3.5. Yeah, this will be good. 3.6. Starting with 3.3, then 3.4, 3.5, 3.6, and 3. And then for x-axis, for y-axis, we have the smallest value as 4.8, and the highest is 5. So you can select a scale minus 4.8, like. Try to extend the scale so your graph is more prominent. So if I start with 4.8, then after 10 boxes, example 4.9, then after 5.0, then 5.1, and so on. So I'll try to cover, but this won't cover. The 5.2 is there, 5.3, 5.4. So this won't cover. Because the minimum value I have 5.7. Yeah. 10 boxes, 10, 10. 2.8, 2.9, 5, 5.1. So if it's not covering, then I have to select 5 boxes equals to 4.8, 4.9, 5.0, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7. So this will be 4.8, 4.9, 5.0, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, and 5.7, and so on. So using this, we'll plot a graph, and what will be the, it will always be an identical graph, which is more towards the x-axis. There will be intercept, x-intercept will be there for this graph. Then we have to determine the gradient. You have to take, after plotting a graph, you have 1 over t and ln k. But don't forget when you, because see, this ln k, the 1 over t is in 10 power minus 3. So that 10 power minus 3, you should add in the calculation. Like when you take 2 points to get the gradient y2 minus y1 over x2 minus x1, that time you will substitute this x2 and x1. You will, like, say the value is 3.3. So you will not write only 3.3, you will write 3.3 exponent minus 3. So in a calculation, you should include those values. Then use your data, use your value for a gradient, calculate the activation energy. So what is activation energy? Gradient multiplied by R will give us the activation energy. So these are the questions related to the assignment, the first assignment, which was about rate and order of the reaction. Any other question or a doubt? Any question or a doubt? Okay, so I'll share this with you.